Very good morning, all. So, myself, Avinash Jail, Assistant Professor, Department of Electronics and Communication Engineering, Sri Venkateswara College of Engineering, SVCE, Bangalore. So, today we are going to discuss about the syllabus content of VLSI design. So, very large scale integrated circuits. Okay, so very large scale integration of circuits designing we are going to discuss in this particular entire syllabus. The subject code follows like 18 EC 72. So coming to the major thing, course learning objectives. When we're discussing about the course learning objectives of this particular course is to enable the students. So what are the various fields it will enable? It will enable like to impart the knowledge of mass transistor theory and CMOS technologies, learn the operation principles and analysis of inverter circuits, design combinational, sequential and dynamic logic circuits as per the requirements. The next one is infer the operation of semiconductors memory circuits. And the last course learning objective is demonstrate the concepts of CMOS testing. So now, the first thing if you take, the impart the knowledge of mass transistor theory and CMOS technologies. So it is something like knowledge. What is the concept of CMOS technologies? What is the concept of mass transistor? How it is been evolved? All those things, the fundamental things we are going to learn. The next objective is learn the operation principles and analysis of inverter circuits. See, once we have the knowledge of this particular CMOS technologies, we are going to the next level. In that particular next level, we are going to learn the operation principles. So next, after understanding the operation principles and analysis of inverter circuits, we are going to understand the next objective, course learning objective is designing of combinational, sequential and dynamic logic circuits as per their requirements. So you know very well that what is meant by combinational circuits, sequential circuits. So combinational sequential is a very primitive dynamic logic circuit. That means what as and all the input is coming, how the circuit is behaving and the circuit is giving the output. That particular concept also we are going to discuss here. So here, not only designing that one as per the requirements is a major consideration we need to do it. Why? Because some circuits need to be very fast. The delay should be very less. All those things, the noise margin should be very less. All those things are the design considerations. We need to take it into consider and then we are going to design and test. The next one is what? Infer the operation of semiconductors memory circuits. See, basically very large scale integration when we are talking about is, so large scale of integrated circuits, that means what IC chips we are going to discuss. So those are built to store the memory, to store the data. So when we are dealing with this particular concept, semiconductors are the materials which are used to manufacture these particular circuits. That is why we need to understand these things, demonstrate the concepts of CMOS testing. So for the students level, okay, so how the particular ones we design the circuit, how that particular circuit is working, are they working as per our requirement? That particular testing concepts we need to do it. So next we will come to the syllabus part of this particular subject. So in the module number 1, okay, so in the module number 1, the introduction. So in the introduction, you can see that the brief history, okay, in the introduction, the brief history of the MOS transistors and CMOS logic we are going to discuss. And then we are going to discuss about the MOS transistor theory. So in that particular MOS transistor theory, the introduction, the long channel IV characteristics, non-ideal IV characteristics, DC transfer characteristics we are going to discuss. So once we are understanding this particular model number one, okay, so in the model number one, the most of the things are the fundamentals. So from the beginning, from the history, we are going to okay, from the history, we are going to understand brief history, how the evolution of mass transistor happened, what is the CMOS logic, okay, complementary metal oxide semiconductor logic, what does it mean? Okay, so all those things we're going to discuss. So in this particular mass transistor theory also, we're going to discuss about the long channel current. IV means what? Current voltage characteristics, a non-ideal current voltage effects, and DC transfer characteristics also we are going to discuss. So here we can see that there are two textbooks for you. So at the end of the session, I will tell you that what are the textbooks names. So as per the syllabus concern, we need to refer the textbook 2 for this particular module number 1. So concepts and what are the topics to be learned from the textbook, that also we have mentioned here, 1.1 to 1.4 of textbook 2. And the second part is 2.1, 2.2, 2.4 and 2.5. So 2.3 is excluded. So model number 2, when we are going for, in the model number 2, the fabrication. Okay, so fabrication, we see, once we understand the fundamental things and all, so we are going for the fabrication. The fabrication course is a very, very interesting topic. So a CMOS fabrication and layout we are going to understand in this particular first topic. And after that, we are going to understand about VLSI design flow. So CMOS technologies and layout design rules. So for this particular topics, we need to refer the content from the textbook 2, that is 1.5 for the CMOS fabrication and the layout. And after that, VLSI design flow, CMOS technologies and all, we need to refer from the 3.1 to 3.3. So after that, MOSFET scaling and small geometry effects we are going to discuss. After that, MOSFET capacitances and all we are going to discuss, that is 3.5 to 3.6 of the textbook number 2. Okay, sorry, textbook number 1. So in the model number 3, we are going to understand the concepts of delay. So in that introduction of delay concepts, transient response, DC relay model, linear delay model, logical efforts of path. Okay, all those things we are going to discuss, and then we are going to discuss about the combination circuit design. So in that particular thing, combination circuits like your adders, okay, so multiplexers, all those things we are going to discuss here. So in the module number 4, we are going to start with the content of sequential circuit design. So after combination circuit, sequential circuits we are going to discuss. So designing concepts will be very, very similar. The same concepts will be applied for the designing of different kind of circuits. So here in the sequential design circuits, the introduction part we are going to discuss, and then we are going to discuss about the latches, flip-flops. Okay. So and then we are going for the what you call for that shift registers, counters and all. See, those are the products of the flip-flops. So that is why when we are able to design this one, that particular design is also very easy. So dynamic logic circuits, that is introduction, the basic principles of pass transistor circuits. So here there is a something called as a combination sequential. After the dynamic logic is also there. That means what, at that particular moment of time, obvious circuit is going to, that is introduction, basic principle of pass transistor circuits, synchronous dynamic circuits technologies, dynamic CMOS circuit techniques, all those things we are going to discuss. And in the model number 5, we are going to discuss about the semiconductor memory. So in that memory part, we understand that there are some different kinds of memory like RAM. Okay, so random access memory only we are going to discuss. Why? Because read-only memory is used for programming. Random access memory will be used for storing the data. So when we are going to use this particular thing to store the data, so we are going to understand the dynamic random access memory, that is DRAM we are going to discuss, and SRAM also we are going to discuss as per the syllabus concern. And at the last part of your syllabus, okay, testing and verification, So the testing and verification, the introduction, logic verification principles we're going to discuss, manufacturing test principles we're going to discuss, okay, design for testability. So all these particular concepts we're going to discuss in this particular module number 5. So after, see, objective is different, outcome is different. Okay. So objective means what? It's something like a aim. So what we are going to aim at. That is what exactly the concept. So once we understand everything, okay, so entire syllabus. So what are the outcomes we can expect? So at the end of the course, students will be able to. Okay, so once you design all these things, we can able to do something. What are the things we can able to do? To demonstrate understanding of mass transistor theory, CMOS fabrication, flow, and the technology scaling. So here draw the basic gates using the stick and layout diagrams with the knowledge of physical design aspects. And the third objective, third outcome, if you are thinking, so it is demonstrate ability to design combination of sequential and dynamic logic circuits as per the requirements. So here interpret the memory elements along with the timing considerations. And after that, interpret testing and testability issues in the VLSI design. See, basically this particular, when you see the outcome, so every outcome is a outcome of one each module, I can say. Okay. So at the last, we can say that when we're talking about the university examination, so here examination will be conducted for 100 marks with a question paper pattern containing 10 full questions, each of 20 marks. So each full question can have maximum of 4 sub questions. There will be 2 full questions from each module covering all the topics of the module. So students will have to answer 5 full questions, selecting one from each module. So the total marks will be proportionally reduced to 60 marks as a semester end examination. ACE marks is 60. And you know that CIE marks is 40. That means what internal assessment marks will be 40. So total 100 marks examination. So the textbook we can refer to as the first textbook according to the syllabus, the textbook 1. Okay, text 1 is CMOS digital integrated circuits analysis and design by Sung Mo Kang and Yusuf Liblibchi. So the third edition, Tata McGraw-Hill edition. So and the second textbook is CMOS VLSI design, a circuits and system perspective. So here the author is Neil H.E. West and David Money Harris. The fourth edition of Pearson Education. So these are the things which related to your syllabus. Thank you for listening.